we're now going to talk about solving some systems of equations. Why we need this is, let's say we have two graphs, x equals y and y equals 2x plus 1. So let's graph these two. Y equals x just goes through the middle. We can plot that several ways. Y equals 2x plus 1 is going to be, it's 0, 1, we have a point, and it's rise and run 2. So it's something around here. The question is, where do these two things meet at this point? Where do they meet? We want to find that. The way we can actually find that point is through mathematics. And we have these two equations. So we're going to try to solve these two equations using each other to solve it. And let's just leave that there to see how close I was. So if we say y equals x, let's plug x into here. This is called the substitution method. So we would have x equals 2x plus 1. Now, we can rearrange this for x, bring the x over, so we get x over here, because it's, I'll do that at another step. 2x minus x minus 1. We just shifted things around. So we have x equals negative 1. Perfect. So negative 1 will be here. And now what's the y value? Well, if the x value is negative 1, we can say that's here. So y must also be equal to negative 1. So I was pretty close. That is how you solve it with substitution. Let's try something a little bit more complicated. If you have 3y equals 2x plus 1, and 2y equals 3x plus 2. So we want to solve this. First thing we need to do for substitution is to rearrange one of these equations for y or x. I'm going to choose this equation for y. So we have y equals 2x over 3 plus 1 over 3, because I just divided both sides by 3. Now I need to plug this in for y over here. So if I plug it in, I'm going to get 2 all times 2x over 3 plus 1 over 3 equals 3x plus 2. So now I need to multiply my 2's into the tops of the fractions. So I get 4x over 3 plus 2 over 3 equals 3x plus 2. Now, the easiest way to do this is multiply both sides of the equation by 3, which is what I'm going to do. So I'm going to get 4x plus 2 equals 9x plus 6. So I multiplied this by 3, this by 3, this by 3, and this by 3. Multiply everything, the 3's cancel here, and I get my multiplication out here. So I get 4x plus 2 equals 9x plus 6. Rearranging this equation, bring the 4 over and the 6 over, I get plus 2 minus 6 equals 9x minus 4x. So we get plus 2 minus 6 is minus 4 equals 5x. Divide by 5, divide by 5, x equals negative 4 fifths. Oh, looks like an 8. Negative 4 fifths. Let's plug that back into one of our equations and solve for y, like this one. So 3y equals 2 onto negative 4 fifths plus 1. Bring the 2 in, so I get 3y equals negative 8 over 5 plus 2. Now I need to divide both sides by 3. So I will divide this by, it's probably simpler if you multiply everything by 5 first. It's not necessarily the best way, but it's simple. So the 5's cancel here. We get 15y equals negative 8 plus 10. Divide by 15 on everything. Oops. And we're going to have, well, first of all, it's easier if we just, let's add them together. So we have 15y equals negative 8 plus 10. Negative 8 plus 10 is 2, so 15y equals 2. Divide by 15, divide by 15, and we get y equals 2 over 15. There, we've solved for the points. This is the point where they match, where these two equations will meet each other. I'm just going to outline these equations. So these two equations on a graph, where they cross, is going to be at this point. Okay, that's great. Let's look at another method for doing this, called the elimination method. And this is my favorite method. So let's put these two right below each other. So we're going to have 3y equals 2x plus 1, and 2y equals 3x plus 1. We want to subtract these two things to get a new equation, because the sum of any two linear equations is going to be equal to that Well, they're going to be in the same system of equations. Let's not talk about that right yet. The way we need to do that is multiply this by 3. I'll use my blue marker here. So I'm going to multiply this by 2, and this by 3. So that's what's going to happen to the whole equations. All that's happening is I'm multiplying this by 3, so I'm getting the same exact equation. Multiplying this by 2, getting the same exact equation. So let's go to our next step here. Multiply by 2, we get 6y equals 4x plus 2. That's 2 times 3y is 6y, 2 times 2x is 4x, 2 times 1 is 2. Then we say 3 times 2y is 6y equals 3 times 3x is 9x, 3 times 1 is 3. So these are our two equations. Now, all we have to do is subtract these two equations. Now, I'm going to put the subtraction symbol in brackets because it's not just negative 6y, it's negative everything all the way across. So 6y minus 6y is 0, 4x minus 9x is minus 5x, and 2 minus 3 is minus 1. This is our new equation to solve for x. Bring the 1 over, we get 1 equals 5x negative, and we divide by negative 5 on both sides, and x is equal to negative a fifth. Now, we could do this again, flip our numbers and multiply for x and eliminate the x, but I would rather just plug it in. So let's go put our x into here. So 2y equals 3 onto negative 1 over 5 plus 1. So we say that 2y equals negative 3 over 5 plus 1. Let's get rid of the 5. 10y equals negative 3 plus 5. Just multiply everything by 5. And then we can say negative 3 plus 5 is 2. 10y equals 2. Divide by 10. Divide by 10. Y equals 2 over 10. We can reduce that to equal to 1/5. So there are our 2 points where these two graphs cross. Hopefully everything worked out all right there. And that's how you do substitution and elimination method.